It's great to be back up here. I was here 2 years ago, and I think it's like one of the best conferences. So yeah, really happy to be here. So we know, or hopefully people know quite a lot about serverless architectures and the fact that we use a lot of async architectures in our day-to-day. But sometimes operating them can be kind of a whole other challenge in terms of the testing and observability. It's quite different to traditional sync architectures. So today we're going to go through a quick, brief history of how we got to where we are today before going into some different testing strategies where I think that I've got a few hot takes in comparison to what I used to talk about a couple of years ago, and talking about observability, recovering, and delivery. So welcome to Sync and Serve. We're going to talk about the history of how we got to where we are today through the lens of a restaurant, which back in the 70s, we've called it Sync and Serve, and that's when the restaurant opened. So welcome Chef Charlie, waiter William, and customer Claire. And they opened this restaurant in the early days in the 70s, and William would take the order. He would take the order to Chef Charlie and wait there, stood while Chef Charlie cooks the meal, and then would take it back to customer Claire. And in the meantime, these other customers are coming along and the restaurant's full. And hopefully this is kind of, you can see that this is analogous to a synchronous request. And this was kind of the early monolithic systems of one server doing one job, and it would be busy, and if it got more requests, then it couldn't scale. So bring on the rise of distributed systems and microservices, and introducing sync and microserve. So the restaurant rebranded, and now they've got different servers, or in this case, chefs, for starters, mains, and desserts. And waiter would go up to one of the customers, ask for a starter, and then go to start Shelly, but meanwhile would still be waiting, so it'd still be a synchronous request because it's waiting for the starter to be made. And that's all good because the next customer actually wants a main, and so the waiter then goes to the main and waits. But then the problem arises when the next customer also wants a main, and main mic is still busy. So this didn't solve the synchronous problem that we're having and the fact that people were struggling to scale. So microservices doesn't actually solve the scalability issue even then, and that went up until the mid-noughties. So then they rebranded as async and serve, and now what we have is a waiter can take the order, it can go to main mic and drop the ticket off, which in our case would be events, go back to the customer, and the next customer wants to order a starter and gives it to starter Shelly, and meanwhile they're all cooking, but the waiter's able to go away and take different orders and drop them off. And so you can kind of see how this is the rise of event-driven architectures and what we see today through the lens of async and serve. So modern day software, just to kind of conclude this part before we move into the different strategies, is so we need to have scalability. So right now we need to be able to handle spiky traffic with ease. And the way that modern day software and async architectures do this is by, say we take the previous example, we just add more chefs, so we'll kind of horizontally scale that way. And you can see that that's kind of analogous to Lambda and how that scales up and down. You still have the microservices in terms of the starter, the main, and the dessert is the different microservices, but they can scale horizontally themselves. We also need our software to be reliable, especially when we're, say you're an e-commerce platform and it's Black Friday, then you'll be losing a lot of revenue if you go down at that time. And we also need to be able to recover when disaster strikes. So in the case of async and serve, we have dessert Dave goes down, and so then we just deploy a new dessert Dave. So that's also kind of similar to the way that we do servers today. We also want to be able to add new features quickly without additional headaches. And so going back to the analogy, we can just add cocktail Chris. And because we've really split these up into domains and we have separate teams managing each system, it's really easy just to tag on a new microservice rather than back in kind of the monolithic days. Tying something in all together could be really complicated and be quite risky as well. And we also need our system to be really observable, and that's something that we'll highlight quite a lot later on in the talk. And of course, we want it to be affordable as well, because we can't run a business at a loss. But all of that still goes to say synchronous requests, of course, still have their place when you need a quick response, such as a front-end call to, say, the bank balance, then, of course, they're still necessary. But just in general, as we've moved through time and now, some of the bigger companies are using a lot of asynchronous event-driven design in order to scale to masses of customers. So, as mentioned, yeah, we want to use events, and the thing is with these, testing strategies are quite different in event-driven systems and asynchronous systems because of the nature of, in particular, latency. So a lot of systems, there might be a small latency, but it's also unpredictable. So you can have tests which are being ran on deployed services, and it's taken a long time to complete, and this is increasing the length of time of your CI/CD pipeline, and henceforth kind of reducing your speed of delivery and recovery if you need to roll things back. Secondly, the challenge of testing is the distributed systems. So often the fact that we've now got these different domains, different teams will own the testing of those domains, but actually the critical flows might be across multiple domains. And therefore it's difficult to know who should be testing what, and sometimes gaps are missed. Gaps are left. And then just what to test, it can be difficult. Some people want to go 100% test coverage, and that can be time consuming and lead to people spending way too much time just writing tests or waiting for CI/CD pipelines. So actually narrowing down, and what we're going to talk about today is choosing exactly what to test and how to test it to get the most efficiency. So I'm sure we've probably all seen this traditional testing pyramid. So on the bottom we've got unit tests, which I'm going to argue that those are the most important, and actually there's so many things that people try to test with integration tests and end-to-end tests that could actually just be done with unit tests, and that's going to be far quicker for everything. Integration tests and end-to-end tests, and we'll dive into that a bit more. So let's take an example of a business. We have a client that, let's say it's got a front end, and that does a synchronous request to make a payment, and that goes through a cart microservice, which asynchronously talks to a payments microservice and marketing and rewards. And we need to decide, firstly, different teams all look after those different services. And so we need to decide how we're going to test these things. And firstly, I would say that we should be identifying which our business critical flows are, so that we can test the things that are actually going to matter. Like if it breaks, then we've got a big problem. So to dive into that a bit more, I think a marketing outage wouldn't be so bad, because a customer may just not receive an email, but it could be retried later with good error handling. So if it goes down, as long as the errors are handled, the customer will still receive the email later, and that's all good. So it's really not too business critical. A rewards outage, which might be kind of VIP points, that's not great. That's probably medium, because when the customer pays, if everything doesn't get updated in rewards, then the customer might be confused when they go back to the page and see that the points haven't updated. So there's like a small customer impact, but it's still not that bad. And then, of course, a payments outage is terrible, because we're not going to be able to take payment, which is going to be the main thing that the business wants. So at this point, we're thinking, okay, well, we need to test payments outage, so let's have a look at that flow. So diving in a little bit deeper, a lot of people decide, well, okay, we'll just deploy both services and then just test the endpoint and check that we get a 200 back. Just check that the cart service returns successfully when we try a few different requests. But but I hate this idea. Firstly, the great thing about it is, yeah, it's going to give the okay if everything's working as expected. But firstly, it's unclear who owns the test, because if the cart service owns the test, they're going to have to also deploy the payment service to make it work. There's going to have to be some kind of deployed version of the payment service for this to happen. It's going to be a really long CI/CD pipeline. You've got to deploy the whole flow in order to test it before you merge. And then if it does fail, then there's no visibility as to where the issue actually lies. At this point, you're thinking it could be in the cart, it could be in payments, it could be with the third-party provider, which is down here in payments. It's just not really telling you much at all. And then again, in this situation, the third party's being tested. So yeah, if the third party goes down, then this test isn't really telling you an awful lot. So given there are such a number of pain points with this method, let's kind of see what strategies I would employ to make this a whole lot better. So we're going to keep track of the do's and don'ts of these strategies. And so the first don't is to use end-to-end tests by default. I would kind of say that's a last resort, because it's just not giving you much at all as an engineer. So let's look at the unit and integration tests. And let's go a bit deeper into the cart and payments flow, which is our business critical flow. So firstly, we want to make sure that the tests are decoupled. So the cart team are looking after their cart tests, and the critical path for payments team is being looked after by the payments team. So firstly, let's go into cart. And I think the first thing to do is kind of to take a step back and kind of get away from traditional just testing thoughts and think about the failure modes that could happen. And I know that this is a really simple example, but you can apply, it's a very common pattern, and you can apply it to other things. So firstly, some common failure modes would be misconfiguration of the IAM roles and ARNs. So if those aren't tested, it's quite easy for that to go wrong. There's also some other failure modes that we'll come back to later, such as throttling of the API and the Lambda. But let's look at the misconfiguration first. So firstly, I think try to go with a unit test first approach, which in the past isn't something that I've always actually done. I've often done unit tests on business logic, but I'm starting to think a bit more now about using unit tests for infrastructure testing in order to not have to deploy the infrastructure to test that things are working in order to speed up the delivery pipeline. So a typical infrastructure test for these IAM roles and ARNs might look something like this. So the stack hasn't been deployed, but we've got the template, and we're testing that the ARNs are correct. And in this case, it's using AWS CDK lib, but I guess you could apply this to whatever infrastructure as code that you're using. So the point here is you're not actually deploying the infrastructure in order to test those configurations, and therefore you don't need to do an integration test for it. Of course, I think that the integration test is probably a little bit safer in terms of you actually testing on the real thing before you go to production. But in most cases, and especially in less business critical flows, then this is going to serve you just fine. And then, of course, I would always go for full coverage of the business logic with unit tests, because I think unit tests just has such low overhead, both in writing the tests and also running the tests, that it's just a no-brainer to do those. So decouple tests as you would your services. Don't have a particular team running tests over the entire flow. And cover as much as you can with unit tests. That's kind of my first rule. So do we really need to add integration tests? The answer is probably for really business critical flows. So in the payment situation, you'll probably want to do that because it's worth the extra time. But in other services, you might not. But here's an example of an integration test and a blog that I wrote on this years ago, which seems to still apply today, where if you've got that API to event bus, then you can deploy that, and then also you can deploy infrastructure for the test. So you can't interrogate an event bus with the AWS SDK, but you can deploy an SQS queue in the test and then interrogate that with the AWS SDK. And therefore, the integration test would be, given that I request something from the API, do I then get a correctly formed event on the SQS queue, which in turn you can assert that it arrived on the event bus. So there's an example of kind of a real-world integration test that you might use. But again, doing this, it's just taking more time. And soon I'm going to kind of argue that that's just as important as test coverage, to have less time, because bugs will always end up in production no matter how many tests that you have. So you need to be able to like revert as quickly as possible and accept that bugs will be there. But you know, if you can come back within a minute, then that's better. So yeah, add integration tests for just critical paths only. So let's dive into payments, where it's a slightly different architecture. And so we've got an event bus, which is triggering a step function, which has some logic in there, and it puts something into DynamoDB. And then we've got some different payment providers, third parties. So another integration test that we can do is to put an event, so deploy the infrastructure, put an event onto the event bus in the correct format, and then check that the item arrived in DynamoDB so we can interrogate it that way. And then another one that we can do is when I send a valid event to the event bus, do I end up with a message back on the event bus? Because in this architecture, it actually does a load of logic, and then it puts another event back on the event bus for the cart service to consume. So you can check on both ends, and you'll need to deploy an SQS queue in order to interrogate the event bridge. But the considerations of this, so what if the process takes a long time to execute? Now, in the example that we gave at the beginning, it's probably going to be quite a short step function because the customer's actually going to be waiting on some sort of a response if the payment succeeded. But let's pretend that we're in a world where this step function is going to take, I don't know, 30 minutes because it's a different scenario. You probably don't want your tests to be waiting around for that long at all. Like, that's a terror. So asynchronous architectures can be problematic in that way in terms of testing because it lends itself to long-running processes. And then another one is like, how will we know if our system, if it's our system or the third party that's having issues? And so this brings us on to the concept of the square of balance, which you might have seen Sheen's talk earlier. He's introduced us to his book, Serverless Development on AWS. And this concept of the square of balance is introduced there by my colleague, Luke Hedger, who also wrote the book with Sheen, and I work with closely now. So we've covered a lot on testing, but the square of balance is kind of trading this off with observing, recovery, and delivery. So you can have 100% test coverage, you can test all those long-running processes, but then your ability to recover and deliver is going to completely go downhill because if things go wrong, then it could take you an hour to get things back into prod, and you want that to be much more snappy. So let's kind of talk about those different trade-offs and what else you should consider. So firstly, an interesting quote that I quite like is from Dijkstra, that testing shows the presence, not the absence of bugs. So again, it comes back to this idea that you can do all the testing in the world, but you still will get bugs, and they'll always be there, so we have to be able to recover and deliver really quickly. And that's just as important as having 100% test coverage. So let's have a look at how we might observe this system. So firstly, I would make use of a lot of CloudWatch alarms. And so I would put those on the lambdas, maybe high lambda errors or throttling, some things that indicate that the system isn't working as expected. Failed step function executions, you might say, if there's a high number of those or a certain percentage, then we should be alerting. And we might do low number of invocations in terms of the step function. So if we've gone a minute without any executions, then alarm bells should be going off. Nextly, we should then be feeding that through to somewhere that actually alerts the team. So Confusing terminology is like the alarm is not what's alerting us to it. We need to actually be alerted as humans to these problems. And so in my team, we would forward these through to MS teams. And if it's really critical, then it's probably going to go through to like PagerDuty or something like that. And a really nice thing that I've been doing recently is using composite alarms. So rather than being alerted, like let's say that the third party went down in this scenario, then you're probably going to get high Lambda errors and failed step function executions and low number of invocations, and the Teams channel is going to be going crazy and you don't know what the problem is. So better to kind of encapsulate all of these into one particular alarm. So all of these events come in and you can go, if any of those are going off, then just say payment service is experiencing issues. You get one alert and then you can go and investigate from there and click through to see which ones are the problems. So this has been really nice, actually, using the composite alarms. So in terms of recover and delivery, again, we want speedy pipeline for reverts and bug fixes. So I notice now that we've really reduced our pipeline. As soon as there's a problem, sometimes it can be really just so quick to get the fix or just revert the PR rather than waiting around for all of these tests. Sometimes we make a bit of use of feature flags as well. If it's a really kind of risky release and it's quite big, then that can be really nice just to turn the feature on and off if it works. And then Canary deployments seem to have worked fairly well for us, especially you'll have a deployment and then if you've gone to 10% and the alarm bells are going off, it'll just stop it there and revert back. But that kind of comes with some issues as well that I've noticed recently where sometimes we have to keep turning Canary off because say you change like an IAM role, AWS doesn't quite work with it because it'll only have one IAM role at a time. Some of you might have come across that problem. It can be a bit of a nightmare to debug. So back to our list, we want to use composite alarms to avoid noise and use alerts to notify critical bugs. So when I say it's kind of a trade-off, sometimes I've come across scenarios where you could spend ages trying to test something that's just a bit awkward to test, but if the test if it's not working for you and it's just a bit of a nightmare to test, then sometimes it's just better to have the alarms in production and have things roll back if you're using Canary and just be able to revert those things really quickly. And so in the don'ts, resorting to 100% test coverage at the expense of speed of delivery and recovery. And I think just accepting that bugs will make it into production. Obviously, it needs to be accepting that they'll make it into the production with good recovery plans. You don't want to just accept that they'll be there forever. So coming back to when I said that we'd come back to the cart failure modes, we had these misconfigurations and we talked about throttling as well. So throttling can happen at the API gateway level, probably caused by Lambda scaling up quickly, something like that. And so Lambda can take a little bit of time to scale up, so you might get some throttles. You don't want to lose information. So many of you may know, like if we don't need a synchronous response, it's probably a good idea to put a queue there so that so that basically the Lambda has time to scale and we can just queue those events up. And the point here is thinking it's not all about testing, it's also just designing your infrastructure properly so that it can handle these the spiky traffic. But you still get throttling on the API for whatever reason, and therefore I'd be putting an alarm on the API gateway for like high 500 errors, and then feeding that back through to Teams so you can understand what the problem is. So another do is to think about prevention and scalability in your actual architecture design, and don't just be relying on tests, because tests aren't going to catch things like throttling. So a question that sometimes I ask myself is, well, if everything's all split up, who's actually looking at the integration between the two services? And I'm sure a lot of us have kind of heard about contract testing, And it still seems to be a slightly unsolved problem in terms of if the cart team changes their schema slightly, how the payments team is just going to break. Because everything's decoupled and you won't have picked it up in a test if someone hasn't done an end-to-end test. So this could be an argument for an end-to-end test, and maybe that does suit you if it's so critical that you just have to do that check. But what I've been doing recently is having like a separate schema package where, in this case, cart team would own the package because they're the producer of the event, and they define the schema, and then the payments team ingests that package and validates against that. And so that way the schema package is kind of a contract between the two teams, and hopefully if people are running tests in both teams, then it's going to get caught when a change is pushed. And it's not going to catch absolutely everything, but I think it's quite a nice pattern, and it does stop you from having to deploy all these services. Or in the past, also we've considered using Packflow, which is like a contract testing tool. And whilst it all looks absolutely great, and I would kind of love to use it, in an enterprise, it's kind of taken a long time to try and get going with it, because you kind of need all the teams buy-in for this to kind of get off the ground and actually have some usefulness, and it costs money. And so this is just quite a cheap and simple way of achieving it. So yeah, make use of schema packages, as it says contacts, but contracts between teams. So the final things that I'd like to leave you with are to think about the testing triangle, which might seem really elementary, but the fact that unit tests at the bottom is kind of, the first port of call. Go unit test first. It's going to give you the most value, and it's going to provide a lot of protection. And then use integration tests on critical paths that are needed, and use end-to-end tests if you really need to. If you really need to. And then the other thing to take away from this, and as I've been harping on about for the last half an hour, is the square of balance. I think for too long we've been focused on testing absolutely everything, and kind of ignoring the fact that we need to observe really well, recover quickly, and deliver quickly. So just trying to make trade-offs when you actually think about it. Don't just accept that you need to have a long-running test. Actually think, do you need that? And so that's everything from me. Again, just kind of a plug for Luke and Sheen's book, Serverless Development on AWS, where a lot of the square of balance is spoken about in there, and I've written a little Q&A on one of the chapters. I hope this was useful. Thank you very much.
This is the fullest room we've had. Thank you, Sarah. So we do have time for questions. I can see hands already going up. So I will run around the room. It's a big room, so bear with me, but we'll start at the front here.
Thank you. When you do decide to do an integration test, do you ever use a kind of fake AWS environment using Moto or local stack or something else?
I actually haven't so much. I think when I came into kind of testing a few years ago, the idea of using kind of fake environments was kind of frowned upon a little bit, especially with serverless offline. I don't know whether you ever used serverless framework and then serverless offline. And it was just a bit of a nightmare mocking these, using mocks for things. And so I was always like, oh, you've got to deploy the infrastructure. But now I haven't used it so much, but I do hear the latest version of local stack is actually really effective. So I think it's definitely something that I should try out and see what my opinions are. I've heard good things about it.
Who else have questions? All right, there's a few at the back, so I'll come towards the back here. Pass it down that way and then pass it over.
Hi, great talk. You talked about unit testing IAC. I was wondering, if you had come up with any thoughts on which bits should be tested and which bits shouldn't, because
Yeah, definitely kind of during this talk, I wanted to hammer home the fact that we should be doing infrastructure tests, and definitely I would always add infrastructure tests. I do think there are scenarios when it is really critical paths, and the reason why I feel like the unit test might not sometimes catch the problem is that often kind of developers may not fully understand these unit tests because I don't think they're really that commonplace yet, and so people might miss out on adding them, or they might just kind of change the output willy-nilly because they don't really know what's going on, but actually now that fits, so let's just get the unit test to pass. So I'm not kind of saying that that's the be-all and end-all, but I think that in less critical services, it could be enough. So yeah, I would kind of say that if it's a really critical service, I probably still would opt for some integration tests just to check that sort of thing. Yeah.
Thanks. I just had a question about the schema packages at the end. Mostly because I lost about 2 or 3 hours yesterday because we don't have something like that. For your business events, is it something you just keep completely centralized that all the domains can call upon, or do you kind of segment it into the separate domains?
So is the question like whether to have one big schema package across all the teams or whether to have separate ones? Yeah, so in my experience, we've done it per team because, again, you kind of want to keep things per domain, and I think the producers of the event should be responsible for keeping the schema. Whether they want to kind of start implementing versions and stuff like that, that's up to them. We actually haven't really done that. It's more just like to pull it and validate, or even we've used the schema package just within the teams. So if you've got your domain and then you've got different services to test for that integration, I think having one central one, I don't think it's necessarily a bad idea. I think it's just that then it's kind of the shared responsibility of everyone, could just get a bit messy, might not follow certain coding standards. So generally I would probably say one per domain, and then you just publish it to NPM so that you can ingest it. Yeah.
Any more questions? I'm right in the middle of the room now, which felt like a good idea a minute ago.
If you were to join a team that had no observability or testing, which one would you implement first and why?
Observability. That obviously that sounds like an absolute nightmare. But I think like observability, I think that you could set up a lot quicker to kind of get a broad overview of everything. You might not be able to set up all of the alarms and alerts, but at least in this situation, someone at least could check the dashboards every day and check that everything's running. Tests, I would hope that you'd start to implement them, but yeah, I'm probably actually favouring observability a little bit more, but obviously it's a tough question. I think they should both be there.
I think we'll do one more question if there is one, and if not, then we'll let Sarah off the hook. That was just as a speaker, it is your worst fear. I don't know if it's the same for you, like that bit at the end with all the questions. So, have we got any more? No? Okay, well, oh, we do. Okay. You're not quite off the hook. Here we go. One sec.
Hi, thanks. It's not really a testing, it's a deployment question. We often have debates about fix forward or rollback as a strategy. What's your view of when you should do which?
So I guess, yeah, when we've come across production issues, you know, if it's just going to be quicker to like revert the PR and merge it in, and it's actually a critical incident, then you better just do that for sure. If you're having an outage where people can't pay or there's a critical path. But if it's like, let's say it's the marketing situation and no one's really going to notice not having their email, then as an engineer, I would probably at least spend like 15 minutes seeing if I could figure it out, and then if not, then just revert and give myself a bit more time to figure it out, because it's probably not the end of the world if you haven't merged that feature in. So I think it just depends on how critical the problem is. Yeah.
Okay, well, thank you very much, Sarah. I think another round of applause. That was a brilliant talk.